Subtracting, what did we learn the rule was for adding and subtracting? There's two.
It's gotta be the same number?
Same number in the inside and the outside.
The little number.
The little number on the outside. So we can't just say the outside number. Why?
Because it could be a big number.
It could be the big one. Okay. So the index is that's what that's called. Okay. This is the index. Right here. This is the index. That's what that's called. Okay, and then we have to have the same number on the inside. Okay, so that was for the addition and subtraction. The multiplication rule is that you have to just have the same index. Okay, so they have to have the same index. If they do not have the same index, you need to stop immediately. Okay, so if there is no index, what number is there? A 2. Okay, so the multiplying radicals, most of them are just underneath. We will start today with some on the outside. So essentially and this first one I'm going to do slow, but when we have them and they have the same index, you can put them underneath the same radical and do like this, 2.6. Okay, what's a dot mean? Times. So really it's going to be 2 times 6, which is what? 12. Okay, and again, when do we have to simplify?
If it's not
When it's not 2,
2, 3, 5, or 7. Okay, so essentially you're kind of doing the same thing. We're going to combine, okay, multiply, and then simplify. Okay, so 12 is going to be 2, 6, 2, 3. So who is able to go?
2.
A group of 2s can go. Who cannot go?
3.
A 3. Okay, for the 5s. Okay, I'm going to show you the long way, and then I'm going to show you a shortcut way. For the 5s, we can put them both underneath the same radical. So 5 times 5, 25. Okay, and then again, is that a 2, 3, 5, or 7? No. Okay, and so we have to make the tree. What's some factors of 25? 5, 5. Okay, so who can go?
One group of 5 on the outside.
One group of 5 on the outside. Now, who goes on the inside?
A 1.
You could put a 1 or nobody's on the inside. It kind of just disappears. Okay, so my answer is just 5 on the outside of radical. Now, look at what happened from the start. What did we start with? 5, 5. What did we end with? 1, 5. Did he have a house or no house? No house. Okay, so when we have this, if you recall, because there's a 2 here, and if they're both the same number, it's really just going to be that number by itself. So if we had like this, 3 square root of 3, my answer is just going to be 3 with no house. Okay, because it's a square root of 9. Square root of 9 is 3. If I have 4, what's my answer going to be? 4 with no house. Okay, so that only works if my numbers start off to be the same. Okay, and they have the same index, and it's really a 2. Okay, so look at number 5. I got 2 times 3. What is that? 6. Okay, what's some factors of 6? 2, 3. So who can go?
Nothing. So 2 goes on the inside, but then it becomes a 6.
Then it still becomes a 6.
I mean, that's just a loop.
Okay, so it is. So sometimes we go to simplify and we actually can't. And so this is the simplified version. It can't get any smaller than that.
So what was, just so the value that is so, basically there's no point in doing that for that.
It was to combine, to
No,
get
I'm
it into a
saying-
single
no,
radical.
I'm saying for
The tree,
yeah.
there was no point, but a lot of you guys didn't know that until we got it done, and then you're like, oh shoot, it actually doesn't simplify. So I would always just check it to err on the side of caution. Okay, 7. We're going to say 3 times 12. 36. Okay, what are factors of 36? 218. 2, 9. 3, 3. Okay, so who can go? One group of 2s, one group of 3s. Who's going on the inside?
Nothing.
Nobody. What do we do with the outside?
Fine.
We multiply it. So that's going to be 6, square root of nothing. So then what happens to the square root?
It just disappears.
It just disappears. My answer is just 6. Okay, we don't leave 6, square root of nothing. Okay, yesterday some of you guys had a problem, and you put, I wish I could know what it was for sure. If there's no number on the outside of a radical, what number is it?
2. Oh, 1.
Okay, it's a 1. Now, if you get something and you got a 0 yesterday, you could do like this. Okay, if we do this, there's really a 1 there. So you guys did this. 0 and a 1 are two different things. Okay, if it's a 0, you have to put the 0. If it's a 1, you can leave it blank. Okay, a lot of you guys thought it was 0, but you never put the 0. You have to put the 0. Okay, number 9, 6 times 15. 6 times 15, what is that? 90? Somebody agree? Is it 90?
Yeah.
Okay.
Yeah.
Okay, 90. What are some factors of 90?
2,
2 and 45? Okay, 45. I'm gonna go with 3, 15, 3, 5. Okay, you can do 5, 9. The problem that I don't like doing that is because then, like, now we see our tree comes down and then it makes like an L every single time. When we start doing that, like, especially, this one's not too bad because the numbers are small, but then we get like some 3s here and some 2s here, and then the other part, you're fairly good at math, so like, you'd be okay, but some people's handwriting is way too sloppy to be doing that. Who can go? One group of 3s.
On the outside, and then 2 and a 5 on the inside.
A 2 and a 5 on the inside. What do we do with that 2, 5?
Times it.
Times it. So we're gonna get 3 square root what?
10.
10. Okay, how is 11 different?
Because we got a -3 on the outside.
Yeah, so now we have numbers on the outside, okay? So when we're doing these then, even for multiplication, what are we always checking to make sure? Before we can even do anything, what do we have to make sure of?
They got the same number outside.
They have the same index, okay, or the baby number, okay? We can't say outside because why?
Oh, because it's big number.
It could be a big or a small number, okay? So, we do have to check that, but, so we multiply the outsides together and then we multiply the insides together, okay? So if we look at this one, what number's on the outside if there's no number?
1.
A 1, so there's really like a 1 right here. Okay, so these ones are gonna get multiplied together, so -3 times 1, -3. 10 times 2,
12.
20. Okay, and then we're gonna factor out that 20. So who? We got 210, 25. Okay, you need to make sure that you drop the 3 down. Okay, don't forget about the 3 before we even start. Okay, you're gonna start with the 3 out there no matter what because that's what it was given to us from the gate. Okay, with the 20, who can go?
One group of 2.
A group of 2s.
And a 5 inside.
A 5 inside,
Multiply.
and multiply. So -3 times 2, -6, square root 5. Okay, 13. We got 6 times 3, 18. So we got 2, 9, 3, 3. So who can go? A group of 3s. Who cannot go? The 2. Kind of. Look at 15. What did we learn that one's going to end up being?
2.
The
Which could be square root.
Okay, so it's going to be,
This would be 2.
okay, hold on. So it's going to be square root of 4, which becomes what?
2.
2
and that's the answer.
with no square root. Okay, so it's just 2. It's not square root 2.
Is there ever a problem like just like this where there is?
I mean, maybe, but, so like if we look, so which one, see how it's just 5 with no house?
Yeah.
Yeah, so the house disappears because the 5's out here.
Oh,
So that's what I was saying, it is 2s, but you need to erase that.
okay.
Which is the one mistake people make, okay? So it's just 2. It's just 2, no house. Okay? It's just 2. Okay, you guys got 8 to do on your own. Go through and get your side done, and then you're done for today.